So in our project, we are trying to solve the issue of the electronics domain industry. And if we look into the electronics market in India, so we manufacture mobile phones. Like 65% of the mobile phones manufacturing is happen in India only. And after that, we also manufacture IT hardware, auto electronics, and consumer electronics also. And all this subdomain of electronics industry requires printed circuit boards as their integral part. And we are we are saying that we only manufacture 35% of the printed circuit boards, and rest all of the printed circuit boards comes from Korea, Japan, and China in our country. So the issue here is, after manufacturing of the circuit boards, we have to do manual inspection whether that PCB which are manufactured are faulty or non-faulty. So if we have to detect that, we have the hardware solution in the market. The hardware solution is using multimeters, oscilloscope, and also there is a manual inspection. In some companies, there is manual inspection also. But as a software company, we are trying to provide software solution for this issue. Like we can detect whether these printed circuit boards are defected or not by software mean, not by hardware. So, and we are happy to say that we have made one minimum viable product which can address this issue, and it is working and it is giving the solution also. So in this PPT, we are going to discuss problem statement, their solution, and what will be the future enhancement for this problem and project. So in problem statement, there are like few challenges in PCB fault detection. So the first challenge we face is like the complexity of the modern circuits, and also the hardware solution issues like high initial cost and also maintenance and calibration. For example, equipment like automated optical inspection or X-ray machines or ICT, which is nothing but the in-circuit testers. These are expensive to purchase and set up, which can cause significant investment for the company. And also for maintenance and calibration, the machine requires regular maintenance to ensure accuracy, which adds up to operational cost and can cause downtime also during the service. And also scaling of the hardware solution involves like purchasing the expensive equipment, making it less flexible and more costly to expand our inspection capacities. And also if we talk about the human error and production cost, so this, because of this also the brand reputation gets hampered, and also the product which we are going to deliver in the market, it gets delayed. So this is a problem statement, and the solution for this is an automated fault detection system. So this system will leverage artificial intelligence, machine learning, computer vision, and image processing technologies to identify the defects in the PCBs. If we talk about what kind of technologies are used in backend, so in backend we have used Google Colab, which is offered by Google, and also like why only Google Colab? Because it offers GPU at cheapest price in the market. Also the Ultralytics YOLO V5, which is a model, YOLO V5 is a model which has maintained and optimized by Ultralytics. Flask for the backend server, and OpenCV for image annotation and data labeling. If we talk about the front-end technologies, so the front-end technology we use is Bootstrap, HTML, and CSS. So clubbing all four, our front-end is getting created. So in this demo, we want to show that how actually the model is running. The actual demo we are going to provide here, and this is the code which is written for that model training and model deployment on a local host. So this is my drive which is connected to this Google Colab, and this is a data set. And if we see in the data set, there is training data set and validation data set, and I have downloaded some of the image to show that how the data set looks like. So this is a circuit board image we can see. And also there are like lot of, this is another one image. So we have to predict the faulty issues inside the CPUs. So here this is the app.py file which we are going to run through Python interpreter. And if we open this app.py file, it is having the complete code of the model and deployment. So this is the code, and I'm quickly going to run this file. This file is running as we see here. So okay, now our it is successfully run, and if we click on this link, it will ask about to visit to the local host from Google Colab. So ngrok will provide a tunnel for this for connecting to our local host, which is nothing but which is located at port number 5000. So after clicking on this visit site, the front end will get pop up. This is the front end which is created by our team. So here we are having the option of browse files. So now we are going to do the actual demo. So here in this pictures folder, I have these images. So I will give this image. I will give this image to the model. So this has been input given to the model. When I will click on process the image, then let's see the magic. I have clicked on process the image, and here we go. Like if we see, the model has predicted here the missing hole. Also here it was an issue in the image, and also here it was a missing hole in in the complete circuit board. So in this way, model will make the bounding box on it. So yes, and now I want to give one demo again. Like in this pictures, we have given the defected image. What if this image we will give? This image doesn't have any defects, so model should not predict anything. So we will now give this image, which is a non-faulty, non-defected image. We will pass in the model. So browse files, and this is the non-faulty image. Okay, now we will click on process the image, and here we go. The model did not predicted anything because there is no fault in this image. So this is the we can say that the model is predicting accurately. Our model is going good. The accuracy of the model is 76% right now, and we can improve this accuracy through advanced GPU and advanced machine learning techniques for sure. So again, let's see if we give any image which is a different one. Previously, we had given the missing hole one. Now this is the image which we are passing to the model. Let's see what this model gives for this image. Open circuits. So it is labeling also where the defect is, and it is giving the name also. If we click on here is an open circuit. The circuit is not closed. Here it is an open circuit. Anywhere now this in this whole image there are two open circuits. So yes, we can say our model is going good. And if we look in this YOLO V5 and in this runs folder, in this training folder, so this is the accuracy matrix of the model, which is nothing but a confusion matrix. So we can say that model has been predicting 0.65% accuracy for mouse bite defect, 0.95% for short. There is a short in the if there is a short defect in the PCB. For spurious copper, the model is predicting with a 0.80, that means 80% accuracy. So yes, this is the accuracy metrics which can be improved further for sure. So yeah, this was the demo. Thank you. Coming towards the future enhancement of this project. So in future enhancement, we can do one thing is like we can build a modern data platform which will give a complete analytics solution to the electronics data which we have collected from the client. We can see here like from the source data points, the data will get collected, and from there we will store it in data warehouse to data mart, and here we will have our analytics services as a machine learning model building. And for the same data, we will offer Power BI visualization services. So this complete analytics package as a service we can provide to the clients. At the end, we want to extend our thanks to you for organizing the hackathon and providing us with this incredible opportunity. Being a part of this hackathon allowed us to learn, innovate, and collaborate with the talented individuals. It was an enriching experience that will undoubtedly contribute to our personal and professional growth. Thank you once again.